All right, when we have an angle, it's made up of two rays and a vertex. And we're going to talk about today what it means if an angle is in what we call standard position. And an angle is in standard position when it's in the Cartesian plane. That's our grid with the x-axis and the y-axis. And it's in standard position when the vertex is right at the origin. And one ray is along the positive end of the x-axis. And the second ray can be pointed out in any direction at all. Let's have this one coming out here. And the ray on the positive end of the x-axis we call the initial side of the angle. And the ray that's pointing out we call the terminal side. And if you'll recall these quadrants, they have, we name them with numbers. This is quadrant 1. And moving counterclockwise, this is quadrant 2. This is quadrant 3. And this one's quadrant 4. And it's tradition to number them with Roman numerals instead of Arabic numerals. And you'll also recall when we studied angles that if you're moving counterclockwise, if you're starting on the initial side and you're moving counterclockwise in that direction, the angle has a positive measurement. But if you start and go clockwise, this direction, your angle has a negative measurement.
All right. So, I'll just use this pen to be good enough. All right. So, again, we've talked about angles in standard position, the initial side being on the positive x-axis, and the terminal side, the other ray that makes up this angle, lies in any other quadrant. That is an angle in standard position. So, again, Mr. Simmons talked about if we sweep that terminal side counterclockwise, it's positive, and if we sweep this angle clockwise, this terminal side clockwise, then that angle is negative, as you guys saw on the worksheet. So, let's look at an example of an angle. Alright, and this being the x-axis, and this being the y-axis. Alright, so let's say that we have, trying to pick a good color here that'll go on top of that. I wonder if red will show up.
Gotta love red and black.
Gotta love red and black.
Red and black, go dogs.
So again, this is our initial side. Let's say that we sweep the terminal side, the other side of the angle, into this position right here, into this position. Again, this is in the third quadrant. All right. Now, what we see is that this angle that's being made, we're going to call this angle theta. And let's say that this angle is about 200 degrees. The question is, what is this other angle right here that makes up, this other angle right here, that makes up, if we were to sweep in this direction to get to the terminal side of the same angle, if we were to sweep clockwise, what would that angle be? Well, we call this other angle that makes up the whole 360 degrees, we call that the coterminal angle. And if you guys remember, co means with, so this is the other angle that is with the original theta. So this is the coterminal angle. So again, we said that this theta angle right here is about 200 degrees. So what would this angle be to make up our entire 360 degrees? You got it. It's about 160 degrees. Not about, but exactly 160 degrees. That is the coterminal angle. So what we see is a coterminal angle is an angle that shares the initial side of the original theta, and it also sweeps back around and makes contact with the terminal side, but just on the other direction. So, are there any other coterminal angles, Mr. Simmons, other than 160 degrees?
Well, what if I made my angle this way? What if I started here, went to the terminal side, and then went another complete rotation? It's a different angle with the same terminal sides, with the same terminal side, and I went a full 360 degrees, then this 200 degrees, for a total of 560 degrees.
Okay, so what you're trying to tell me, Mr. Simmons, is this is also a coterminal
This is
angle to theta of 200 degrees?
Also a coterminal angle. And if you wanted, you could go an additional 360 degrees and have a 920 degree angle.
Really?
Really?
All right, I got a question. Here, when I said this was 160 degrees, we said that we were sweeping clockwise. Now, if we remember from the previous slide, let's go back, if you will. From the previous slide, we said if we swept clockwise, that was going to be a negative angle. So, what this should be right here is a negative 160 degrees, not a positive. It is 160 degrees, but because of the direction that we swept that terminal side clockwise, it makes it negative. So, anyway, we now have discussed that we can continue after 200 sweeping another 360, which we said now makes a 560 degree angle, which is also coterminal to our original 200 degree theta. We could continue to sweep an additional 360 degrees, sharing the terminal side. That's 920 degree coterminal angle to the 200 degree theta. But like we said, we could also sweep this way. So I believe, if I'm not mistaken, we could continue this around again. Well, this is really busy, isn't it? So if we take our negative 360 and to continue to sweep in a clockwise manner, we get we add an additional negative 360 degrees. It's negative 520 degrees. That is also a coterminal angle to 200 degrees. So, Mr. Simmons, let me ask you this question.
Yes, sir.
How many positive or negative coterminal angles do we have to this 200 degree theta?
Well, the answer to that question is how many times can we add or subtract 360 to that angle? And it just depends on how patient you are.
Oh.
You could do it any number of times. There are actually an infinite number of coterminal angles for each and every angle.
Oh, okay, so I see. So let me ask you this, Mr. Simmons. You seem to have a pretty good handle on this.
Well, I like to think so.
If I were to give you an angle of theta, and let's just say that this angle, Mr. Simmons, happens to be 45 degrees, could you then give me a positive and negative coterminal angle for this theta 45 degrees?
Absolutely. For a positive, all I need to do is add 360 degrees, which would give me 405 degrees.
Ah, okay.
For the negative, I need to either add a negative 360 or subtract of 360 degrees, and I will get a negative 315 degrees.
Aha, I see. I see.
All you're doing is adding and subtracting multiples of 360.
Well, okay, I see that. Is there another angular measure we can use besides degrees?
Sure. And we can stick with 45. If you remember from the Khan Academy video, we have both degrees and radians. And we know that a full rotation is 360 degrees is 2 pi radians. We know 180 degrees is 1 pi. Half of 180 is 90. Half of pi would be pi over 2. And I know 45 is half of 90 degrees.
That's a half of a half.
And a half of a pi is a fourth pi. So pi over 4. So instead of, for my positive coterminal angle, instead of adding 360, I'm going to add its radian equivalent, 2 pi. And there's a calculator trick. You can do this. Leave out the pi's, add it, convert it to a fraction, and stick the pi back in. But I'm kind of old school. I actually like finding common denominators.
He likes finding common denominators.
So 9 pi over 4 is a positive coterminal angle to pi over 4. And to get my negative, I'll just subtract 2 pi. And I get negative 7 pi over 4 for a negative coterminal angle.
So this is the first positive coterminal as we continue to route counterclockwise from pi over 4, which is at the 45-degree first quadrant. If we wrap all the way around and come back to pi over 4, we're actually at 9 pi over 4.
That's pi over 4, 9 pi over 4.
Ah, that makes sense. And tell me again about this negative 7 pi over 4.
Negative 7 pi over 4. Again, we always start at the initial side, and we're going clockwise.
Ah, negative 7 pi over 4. Again, sharing the terminal side, that's where the coterminal comes in. Co meaning with. They're sharing that. And I could continue to add 2 pi or 8 pi over 4 to this to get more positive
as
coterminal.
many times as you'd like.
And likewise, I could continue to subtract 2 pi or negative or 8 pi over 4.
Absolutely.
I see. Okay. So I've heard there's another angle measure that we could bring in here. You know, we have the original standard position, initial side on the positive x-axis, terminal side somewhere else in the quadrant, in another quadrant, and we've got coterminal angles which share the terminal side just by adding and subtracting 360 degrees or 2 pi. I've heard something that is called a reference angle. Have you heard of this reference angle?
Absolutely. A reference angle is the measurement, the shortest measurement from the terminal side to the x-axis. So let's say we have an angle here in the second quadrant. Its reference angle, but let's put a number on it. Let's say this is 120 degrees. Okay. Its reference angle will be the shortest distance to the x-axis. Now the reference angle, we always measure it as a positive measurement, no matter what way, whether we go clockwise or counterclockwise. So if it's 180 degrees all the way to here, that's going to be 60 degrees. If we have an angle in the third quadrant, all right, and let's just say that's, let's say that's, say 250 degrees. You think that shows up well?
Yeah, I think so.
So my 250 degrees is that measurement. The reference angle, shortest distance from the terminal side to the x-axis.
Oh yeah, shows up well.
Okay, it's going to be the 250 minus the 180, which in this case would give me 70 degrees.
So what you're saying here, if I get this correct, no matter where that terminal side is, we just need to get as close as we can to some x-axis, whether it's the positive x-axis or the negative x-axis.
The closest. And because we're doing this, the reference angle is always 90 degrees or smaller. It can never be bigger than 90 degrees. Because if I were to measure the reference angle here, well, that's not the smallest angle. That's not the shortest distance to the x-axis. It's actually this side,
Oh, I see.
that part.
So then we can actually say that our reference angle is an angle measure between 0 degrees and 90 degrees, or if we use radians, that 0 degrees is actually
It's still 0 radians.
0 radians or 0 pi radians, it doesn't matter, and pi over 2 radians. Alright, so another way you might see this, guys, is this, that a reference angle is somewhere between 0 degrees and what do you want to call that reference angle? Just RA?
Sure.
And then 90 degrees. Now if you'll notice, these two inequality symbols here that I've got, they don't have the bar up under them. They're just the inequality symbols, because the bar means equal to, which would then include 0 and include 90. So that brings me to another question here. I'm gonna ask Mr. Simmons a question. Let's see just how good Mr. Simmons is. If I, Mr. Simmons, were to have an angle with the initial side here, and I were to have the terminal side on the positive y-axis to make a 90-degree
Sure.
right angle, what would be the reference angle if, there we go, if my theta was 90 degrees? What would be my reference angle in that case?
Well, if we were to measure the closest distance from the terminal side to the x-axis, if we measured it this way, we'd have 90 degrees. But if we measured it this way, we'd also have 90 degrees.
So which one of those 90s do we go with?
Well, they're both 90. So the reference angle, I'm assuming, would be 90 degrees.
Ah, got him. I knew I would get him. Dadgummit. The reference angle, guys, in this case is actually none. It doesn't have a reference angle. The reason it doesn't have a reference angle, let's just quickly return. If you'll notice, it has to be between 0 and 90. So with me sitting dead on the 90 degrees, there is no part, if you remember what Mr. Simmons says, to get us closest to the
There's
X.
no singular closest measurement.
Exactly. So we don't have a reference angle in that case, in that example.
And would that also hold for 270 degrees?
Yes, it would.
Okay.
And it'll also hold for 180 degrees. If I'm trying to get to an x-axis, but I'm actually on the x-axis, I'm already there. So I don't have a reference angle. That's kind of cool.
Yeah.
Alright, so one quick question before we close this video
Okay.
out. I know we're getting long and lengthy and they're getting tired and they're yawning and stuff. One quick question. What are these angles called, these that are exactly on the x-axis? What are these little things called right here?
Well, they separate the quadrants from each other.
Ah,
So we call them quadrantal angles.
quadrantal angles.
Your 90 degrees, 180, 270, or pi over 2, pi, 3 pi over 2, 2 pi. Those are our quadrantal angles.
Alright guys, that's all we have for today. I hope you guys
That's
learned
it.
something about coterminal and reference
I know
angles,
I did.
quadrantals. So guys, thanks for paying attention and good luck on this lesson.